Henry Ford's most world-changing machine was not the Model T, and that is the uncomfortable truth behind the myth of the assembly line.
Ford did not invent the automobile.
He did not invent every principle of mass production. He did not, alone and from nothing, create the modern factory. But at Highland Park, Michigan, just outside Detroit, Ford Motor Company fused older ideas into a system powerful enough to change the meaning of work itself. Interchangeable parts, subdivided labor, moving material flow,
Specialized machinery.
timed motion, higher wages tied to company control.
These were not separate details.
Together, they became the machine. And that machine had two faces. One face made the Model T cheaper, faster to build, and available to many more American households than earlier automobiles had been. The other face narrowed factory labor into repeated motions, paced by a line that did not get tired, did not slow down for conversation, and did not ask whether a worker still felt connected to the thing being made. That is the tension at the center of Highland Park. The same system that helped democratize the automobile also helped discipline the worker.
The popular version is simpler.
It often imagines a single breakthrough. A line begins to move, cars roll forward, and modern production is born. But the historical picture is more complicated and more revealing. Ford's assembly line was not one machine installed on one day. It was a developing production system, tested first on smaller operations and then expanded toward the full automobile. In April 1913, at the Highland Park Plant, Ford used a crude moving assembly line for magneto assembly. Workers placed V-shaped magnets on Model T flywheels, then pushed the workpiece along to the next worker. It was modest, almost rough. Yet, inside that small component line was the shape of something much larger. The idea that the work should move and the worker should remain in place. That reversal mattered. Before the fully developed moving line, assembly could depend on workers gathering around a product, bringing skill and motion to the job. In the Ford system, the job itself was broken apart. Each task became smaller. Materials had to arrive at the right moment. Parts had to be standardized enough to fit without long adjustment. Machines had to be specialized enough to make repeated operations predictable. The factory floor had to be organized not simply as a building, but as a path. The automobile did not begin with Ford. Britannica notes Henry Ford's central role in the mass-produced automobile, while also making clear that he was not alone in pursuing the mass market. Ransom E. Olds had earlier pursued that market with the curved-dash Oldsmobile in 1901. The broader industrial world had also been experimenting for a long time with standardization, division of labor, and mechanized production. Ford's achievement was not that every part of the system was new. It was that Highland Park made the combination visible, forceful, and repeatable at extraordinary scale. That is why the word Fordism came to mean more than one company's method of building cars. Britannica frames Fordism as the mass production of standardized goods on a moving assembly line using dedicated machinery and semi-skilled labor. The phrase carries an entire social arrangement inside it. Standardized products, high volume, lower unit costs, workers assigned to narrow tasks, and management seeking to control not only production, but the conditions that kept production running. At Highland Park, this arrangement took shape around the Model T. The car itself had been introduced in 1908, and over its production run from 1908 to 1927, Ford produced more than 15 million of them. Its price fell dramatically over time. Sources give $850 at introduction and about $260 by the mid-1920s. Those prices were not just sales figures. They were evidence of a new relationship between production engineering and consumer life. If a factory could reduce the time and cost of building a car, the automobile could move from luxury toward mass ownership. But there was a human equation underneath the price drop. The moving assembly line reduced Model T assembly from about 12.5 man-hours under station assembly to a little over 1.5 man-hours, often summarized as 93 minutes. That compression of time is impressive, but it was not magic. Time disappeared from the finished car because work was reorganized. Motions were simplified. Waiting was attacked. Walking was reduced. Parts came to workers instead of workers traveling through the factory. The product advanced in a controlled sequence, and human effort was fitted to that sequence. For management, this looked like efficiency. For many workers, it could feel like surrender. The line set the pace. A worker repeated a narrow action again and again while the work moved past. Skill did not vanish completely, but the system pushed towards semi-skilled labor, divided into smaller operations. The workers' control over timing and method shrank. The factory became more productive and the job became more monotonous. The evidence of resistance is in the turnover. Ford workers disliked the repetitive new assembly line discipline enough that late 1913 labor turnover is reported by the Henry Ford as roughly 380%, while another Henry Ford article gives about 370%. However the precise figure is stated, the meaning is hard to miss. Many workers did not simply celebrate the new system, they left it. Ford's answer was not only mechanical, it was also social and financial. On January 5, 1914, Ford announced the $5 day with Vice President James Couzens. It was tied to an 8-hour day and compared with an earlier daily wage of about $2.30 to 34 cents for a 9-hour day. The announcement became one of the most famous labor moments in American industrial history, and for good reason. It made Ford jobs far more attractive. It helped stabilize a workforce under pressure from the pace and repetition of the line. It connected the factory system to a broader promise: higher wages, more consumption, and a working class able to buy more of what industry produced. But even that promise had conditions. The $5 day was not simply an unconditional wage increase. It included profit-sharing requirements monitored through Ford's Sociological department. That department investigated workers' home lives, habits, housing, savings, and conduct as part of the company's welfare and control program. Dean Samuel Marquis is associated in sources with Ford's social welfare supervision. In other words, Ford's system did not stop at the factory gate. The company that timed motion on the shop floor also took an interest in the behavior of workers beyond it. This is where the Highland Park story becomes larger than an invention story. It becomes a story about modern industrial capitalism, mass production and mass consumption, higher wages and employer surveillance, efficiency and exhaustion, cheap goods and narrowed work. The system that made cars more affordable also made labor more measurable. It pulled workers into a new rhythm and asked them to live with its demands. Highland Park became the symbol of that transformation because it brought so many pieces together in one place. The plant was designed by Albert Kahn. It would become known as the Crystal Palace because of its extensive glass in roofs and walls. Its spaces were not just containers for machines. They helped make high-volume production possible, with visibility, light, and floor organization suited to the movement of parts and people. Later, the plant would be listed on the National Register of Historic Places in 1973 and designated a National Historic Landmark in 1978. Those honors recognized not merely an old factory, but a site where a new industrial order took form. Still, before the line could become famous, Ford needed more than an idea. He needed scale. He needed a factory built for flow. He needed space large enough to turn the Model T from a successful car into the center of a production system. That requirement takes us back from the myth to the ground beneath it, the move from the Ford Piquette Avenue plant in Detroit to Highland Park, and the decision to build a place where the work itself could begin to move. The move to Highland Park begins, then, not with a moving chain or a celebrated stopwatch, but with a problem of space. Before Ford Motor Company could reorganize work around flow, it had to leave behind a factory built for an earlier stage of its own ambition. That earlier place was the Ford Piquette Avenue plant in Detroit, Michigan. It was not a failure. In the history of the Model T, it was essential. The Model T was introduced during the Piquette Avenue years, and the building belongs to the story because it was one of the places where Ford's car became more than an experiment. It became a product with demand behind it. But demand can change the meaning of a building. A factory that once seemed adequate can become a constraint. As the Model T moved from promise to volume, Ford faced a practical question. How do you build more cars when the building itself begins to resist the pace of production? At Piquette Avenue, the company could assemble automobiles, but it could not yet fully become the kind of system Ford's managers and engineers were reaching toward. The future assembly line required more than workers standing at benches, more than machines arranged wherever space permitted, more than parts moving through a crowded plant by habit and improvisation. It required room for a new logic, materials entering, work advancing, parts meeting at the right place, and finished automobiles emerging with less delay. That logic did not yet have its famous form. In 1910, Ford was still years away from the crude moving magneto line of April 1913 and from the wider chassis line experiments that would follow. But the precondition was already clear. If production was going to grow, Ford needed a site where the factory could be planned around scale rather than squeezed into it afterward. The decision had been prepared before the move itself. In September 1907, Henry Ford bought a 130-acre tract in Highland Park, Michigan, a small city just outside Detroit. The size of that purchase matters. It was not simply a search for a larger room. It was a claim on enough land to imagine expansion, movement, and coordination on a different order. 130 acres gave Ford Motor Company something Piquette Avenue could not easily provide, a physical field for industrial growth. On such a site, the company could think in terms of buildings, yards, approaches, and internal routes. It could imagine not only where workers stood, but where materials arrived, where parts were stored, where machines were placed, and how work might pass from one stage to the next. Construction began in 1908. The plant that rose there would become associated with Albert Kahn, the architect whose work helped define the appearance and function of the modern industrial building. But before we look closely at the glass, reinforced spaces, and the nickname that would later attach to Highland Park, it is worth pausing on what the construction itself meant. Ford was building ahead of the system that would make the plant famous. That is one of the quiet reversals in this story. The moving assembly line did not simply appear and then demand a home. The home came first. The ground was purchased. The buildings began. The company moved Model T production from the Ford Piquette Avenue plant in Detroit to the larger Highland Park plant in Highland Park in 1910. Only after that move could the experiments of 1913 and 1914 unfold at the scale that made them historically powerful. This does not mean the line was already fully planned in every detail when Ford bought the land. The evidence points to a more gradual process. Ford's achievement at Highland Park was refinement and integration. Ideas about interchangeable parts, task subdivision, specialized machinery, and moving material flow already had histories of their own. What Highland Park supplied was the setting in which those ideas could be drawn together around one product, the Model T, and tested under pressure. Piquette Avenue belonged to the stage when Ford was proving the car. Highland Park belonged to the stage when Ford would try to reorganize production itself. That distinction is important because it helps separate the legend from the mechanism. The legend often looks for a single moment of invention. A chain begins to move, a car advances down a line, and modern industry is born. The mechanism is slower and more material. It begins with land. It continues with construction. It depends on floor space, structural design, access to light, room for machinery, room for people, and the ability to lay out work in sequences that can be repeated. A production system is not only a method, it is also a geography. At Highland Park, geography could be made to serve volume. The plant was located in the Detroit metropolitan area, close to the growing world of automobile manufacturing, but no longer confined by the limits of the earlier Detroit building. This mattered because the Model T was not a luxury object to be built in small numbers for a narrow market. Ford's ambition was mass production of a standardized car, and that ambition demanded a factory capable of absorbing repetition. Repetition has a physical footprint. The same task done again and again must be supplied again and again. Parts must arrive predictably. Tools must be near the hands that use them. Workers must be positioned so that their motions fit the movement of the work. If the aim is high volume, confusion becomes expensive. Distance becomes expensive. Waiting becomes expensive. Highland Park offered Ford the chance to attack those costs at the level of layout. The move in 1910 therefore marks the first real turning point in this episode. Not because the assembly line was already there in its mature form, but because the old container was left behind. Ford Motor Company stepped from a plant where the Model T had been born into a site where the Model T could become the center of a production regime. The difference can be imagined as a shift from making cars in a building to designing a building for making cars. That shift is easy to overlook because machines are more dramatic than walls. Chains, hoists, conveyors, and moving chassis draw the eye. But all of them need an environment in which their movement makes sense. A chain-driven line cannot transform production if the factory around it prevents steady flow. A carefully divided task cannot create speed if parts arrive late or workers are crowded into awkward corners. Scale is not only the result of the system, it is one of the conditions that allows the system to exist. This is why Highland Park should not be treated merely as a bigger address. It was the physical foundation for a new production system. The 130-acre purchase in September 1907 gave Ford room to imagine growth. The beginning of construction in 1908 turned that land into an industrial project. The transfer of Model T production in 1910 put the company's central product into the new environment. Each step brought Ford closer to the possibility that work itself could be reorganized. And the timing reveals something else. The factory preceded the most famous experiments. When the magneto line appeared in April 1913, when workers placed V-shaped magnets on Model T flywheels and pushed the workpiece along to the next worker, that small experiment happened inside a larger context already created by the Highland Park move. When Ford later expanded the moving line idea to chassis assembly during 1913 and 1914, those experiments depended on the plant's capacity to handle more than isolated benches. They depended on a place where the movement of parts, workers, and partially assembled cars could be coordinated. The move from Piquette Avenue to Highland Park was therefore not a pause before the story begins. It was the beginning of the story's industrial logic. At Piquette Avenue, Ford had a successful car and a growing company. At Highland Park, Ford had the space to turn success into a system. The difference would become visible in output, in prices, in wages, in worker turnover, and in the rhythm of factory life. But before those consequences could unfold, the company had to make one decisive commitment: to build for volume before the full method of volume had been perfected. That commitment is what gives Highland Park its historical weight. The plant was not just where Ford's assembly line happened. It was part of how the assembly line became possible. Soon, the building itself would become famous. Its glass-filled roofs and walls would lead people to call it the Crystal Palace. Its reinforced spaces would help shape how machines, materials, and human motion could be arranged. The architecture would not stand apart from the invention. It would become one of the invention's working parts. At Highland Park, the decision to build for volume became visible before the moving line itself became famous. It was visible in the scale of the site, in the arrangement of the factory, and especially in the building's unusual openness to light. The plant that Ford Motor Company raised in Highland Park, Michigan, was designed by Albert Kahn, the architect whose name would become closely tied to the industrial landscape of Detroit. And over time, because of its extensive glass in roofs and walls, the Highland Park complex gained a nickname that sounded almost too delicate for a place of heavy manufacturing: the Crystal Palace. The name can be misleading if we hear only romance in it. This was not a palace in the old sense. It was not a monument built to display wealth apart from work. It was a factory, and its importance lies in the way it made work visible, repeatable, and organizable. The glass mattered because the work mattered. The reinforced spaces mattered because machines, materials, and people had to be arranged in new relations to one another. Highland Park was not merely a container for Ford's production system. It was one of the conditions that made that system possible. Albert Kahn's role was central because the factory Ford needed was not simply a larger version of the Ford Piquette Avenue plant. The earlier plant had served an earlier moment. Highland Park had to serve a company preparing for scale before the full method of scale had been perfected. That distinction is important. The moving assembly line would later become the symbol, the image people remembered. But before the line could be refined, Ford needed long, usable factory spaces, strong floors, and a layout that could accept rearrangement as experiments changed the path of production. In that sense, the building was designed for a future that was not yet fully known. The exact motions of the magneto line, the chassis line, and the later chain-driven arrangements were still ahead. But the architecture made room for them. Reinforced construction allowed broad industrial spaces to hold the weight and vibration of high-volume automobile production. Glass in roofs and walls brought daylight deep into the work areas. The result was not just brighter rooms. It was a different way of seeing the factory. Visibility is easy to underestimate in a factory story. It sounds passive, as if light simply makes a room more pleasant. But in high-volume production, Visibility becomes a management tool and an engineering condition. Supervisors need to see where material is piling up. Workers need to see the parts and motions in front of them. Engineers need to observe where time is being lost, where movement is awkward, where a tool is too far from a hand, where a workpiece pauses when it should keep moving. A dark, crowded, segmented factory hides these problems. A bright, open, glass-filled factory exposes them. That exposure was part of the work story. Ford's system depended on breaking production into smaller operations and then coordinating those operations in sequence. To do that, the company needed more than machines. It needed a floor that could be read. The route of parts had to be watched. The position of workers had to be adjusted. The placement of tools, benches, conveyors, hoists, and platforms had to be made part of a larger rhythm. Highland Park's architecture helped turn the factory floor into a visible diagram of production. This is why the Crystal Palace belongs inside the invention, not beside it. The assembly line was not only a mechanism that moved a product past workers. It was a way of organizing time and space. It required a building where work could be divided, aligned, and connected. The factory had to make it possible for material to arrive where it was needed, for partially assembled components to continue forward, and for the path of production to become less like a collection of separate jobs and more like a continuous flow. At Highland Park, that flow was not born complete. It would emerge through experiment. But the plant gave those experiments a stage large enough to matter. Inside the reinforced and glass-filled spaces, Ford Motor Company could test how one operation related to another. It could ask whether a part should move to a worker, rather than a worker carrying himself and his tools around a stationary product. It could observe whether small improvements in motion, repeated across many workers and many cars, would become large changes in output. The architecture also carried a quieter meaning. Earlier factory work often depended on clusters of skilled laborers, assembling or shaping products with more local control over their tasks. Highland Park pointed toward a different order. Its openness, its scale, and its capacity for organization supported a system in which the product's route through the factory became increasingly important. The building encouraged managers and engineers to think not only about what each worker did, but about where each worker stood, how long each motion took, and how the work of one person connected to the next. This did not make the human question disappear. It made it sharper. A bright, rational, well-ordered factory could increase output and reduce wasted motion. It could also prepare the way for labor that was more closely paced and more narrowly defined. The same features that helped Ford organize production at unprecedented scale also helped management observe, measure, and discipline the work. The Crystal Palace was filled with light, but that light did not simply symbolize progress. It also illuminated the changing balance of control inside the factory. The nickname itself invites a useful contrast. A palace suggests grandeur. A crystal palace suggests transparency. Highland Park had both, but in industrial form. Its grandeur lay not in ornament, but in capacity. Its transparency lay not in democratic openness, but in the exposure of work to coordination. What made the building modern was not that it looked beautiful from a distance, but that it helped bring machines, materials, and labor into a common field of vision. That field of vision mattered because Ford was trying to build the Model T not as an occasional product, but as a standardized object at very high volume. Standardization was essential. Interchangeable parts, specialized machinery, and subdivided labor could only reach their full force when they were arranged in a physical environment that supported repetition. A worker performing a small task over and over needed the right part at the right moment. A machine dedicated to one operation needed a steady supply of material. A partially completed car or component needed a route that could be repeated without confusion. Highland Park's architecture helped make those arrangements practical. The building therefore changed the meaning of industrial space. The factory was no longer only where production occurred. It was an instrument for shaping production. Its floors, windows, walls, roof spans, and open areas formed part of the method. Space itself became productive. Light became productive. Visibility became productive. The arrangement of the plant became a way to reduce hesitation and make motion more continuous. This is not to say that architecture alone created Ford's mass production system. It did not. Ford's breakthrough at Highland Park came from integration, standardized parts, divided tasks, moving material flow, specialized equipment, and later wage policies that tried to stabilize a workforce under the new discipline. But the building gave those elements a place to meet. Without a factory designed for scale, the moving line would have been a smaller experiment, trapped inside older limits. Highland Park made it possible for experiments in flow to become a general method. By treating the Crystal Palace as part of the invention, we can see the assembly line more clearly. It was not a single dramatic moment when someone attached a chain and modernity began. It was a gradual reorganization of work, and the building was one of the tools of that reorganization. Before the famous rhythm of the line, there was the architectural rhythm of bays, floors, light, and open space. Before the car moved continuously, the factory had to be arranged so that movement could be imagined, tested, watched, and improved. Inside Highland Park, the future of work was being prepared in concrete, glass, and floor plans. Material could be staged. Labor could be positioned. Motion could be studied. The Model T could be broken into operations and then put back together as a sequence. The plant became a stage on which every object had a place and every delay could become a problem to solve. And because the factory made motion visible, it also made the next step more likely. The first proof would not come from a complete automobile gliding smoothly past a row of workers. It would begin with something smaller, rougher, and easier to overlook. A component of the Model T, a flywheel magneto, a set of V-shaped magnets, and workers pushing the workpiece along by hand. In the glass-filled spaces of Highland Park, the idea of moving work from person to person was about to become practical. The building made the experiment possible, but the first experiment did not look like the legend. At Highland Park, the moving assembly line began not with a complete Model T, not with a polished, chain-driven procession, and not with the image that would later define 20th century factory work. It began in April 1913 with a small part of the car, the Model T flywheel magneto. It was a modest component, easy to miss beside the larger drama of chassis, engines, wheels, and bodies. Yet that modesty is exactly what makes it revealing. The magneto line shows the Ford system before it became iconic. It shows the idea in its crude, practical form. Take a job that had been done in one place, divide it into smaller operations, arrange workers in sequence, and move the workpiece from one person to the next. The point was not yet the spectacle of the whole automobile in motion. The point was simpler and more radical. The work itself could be made to travel. The Model T flywheel magneto was part of the car's electrical system. In the Highland Park experiment, workers placed V-shaped magnets on flywheels. The operation was not hidden inside a fully automatic machine. It depended on hands, timing, placement, and repetition. One worker performed a limited task, then the workpiece was pushed along to the next worker, who performed another limited task. The line moved because people made it move. That detail matters. The first crude Ford moving assembly line at Highland Park was not a seamless machine, swallowing raw material at one end and releasing finished cars at the other. It was a work arrangement. A flywheel with magnets became the object around which labor was reorganized. The workers did not gather around a stationary job and complete it as a group. Instead, the job passed through them. And that shift was the seed of something much larger. Before this moment, Highland Park had already provided the conditions: light, floor space, visibility, and the possibility of arranging materials and workers in planned order. But a building, even a remarkably open one, does not by itself create a new method of production. Someone still had to ask whether motion could be used as a tool of management. Someone had to test whether a part could move through a sequence of hands faster, more predictably, and with less wasted effort than under older methods. The magneto line answered that question at the scale of a component. It is tempting to skip over this stage because it is not dramatic. The image of workers pushing flywheels along by hand lacks the force of the later chassis line. There is no need to imagine the full length of a Model T advancing through the plant. There is no chain as symbol, no completed automobile emerging as proof of a new age. But history often becomes clearest before it becomes famous. In April 1913, the assembly line was still an experiment, and because it was still an experiment, its logic is easier to see. The work was broken down. Each task became narrower. Each worker's responsibility became more specific. The part moved forward. The sequence itself became the organizer. Instead of relying mainly on a worker or a team to decide how to move through a larger job, the arrangement of the line suggested what should happen next. The physical path of the workpiece began to shape the behavior of the people around it. This was not only a mechanical change, it was a change in authority inside the factory. When the workpiece moves from station to station, the layout begins to give orders. The next task is waiting. The next worker is positioned. The next motion has been anticipated. The worker does not need to decide the overall sequence. The sequence has been built into the process. At this early stage, the system was still rough. The flywheel magneto work moved because workers pushed it along. That crudeness should not be treated as a failure. It is the reason the scene is so important. It shows that Ford's assembly line did not arrive as a single finished invention. It emerged through experiments in flow. The company did not begin by moving the heaviest and most complicated object in the plant. It began with a component that could be handled, observed, and reorganized. A small part made the larger question manageable. Could a complex product be treated as a chain of simple actions? Could the time between those actions be reduced? Could workers be arranged so that each repeated a narrow motion while the object advanced? Could materials arrive in the right place at the right moment without forcing the whole process to stop? The magneto line did not answer all of those questions for the automobile, but it gave Ford a proof of concept inside Highland Park. The experiment also reveals why the assembly line was more than a conveyor. A conveyor can move an object, but the Ford system required more than movement. It required standardized parts that could be fitted without long adjustment. It required tasks that could be separated and repeated. It required a factory floor where the order of work could be planned. It required managers and workers to think of production as flow, not as a collection of isolated jobs. The Model T was especially suited to this effort because it was a standardized product. Ford was not trying to build a small number of custom automobiles, each requiring its own decisions and adjustments. The company was trying to build the same car in great volume. That ambition made the magneto line valuable. If a component of the Model T could be assembled through a moving sequence, then perhaps other components could be treated the same way. If enough parts could be organized into moving sequences, then perhaps the car itself could become the final expression of the same idea. This is where the smallness of the magneto line becomes powerful. It reduced the problem to a visible pattern: worker, task, movement, worker, task, movement. The pattern could be studied. Delays could be noticed. Motions could be simplified. The distance between operations could become part of the calculation. In an older factory arrangement, time might disappear into walking, searching, waiting, lifting, or repositioning. On a moving line, those lost moments became easier to see because they interrupted the flow. Highland Park's glass and open spaces helped make that interruption visible. The plant did not merely contain the experiment, it allowed the experiment to be watched. The flywheel magneto line belonged to the same story as the architecture because both were about making production legible. The building organized space. The line organized motion. Together, they turned work into something that could be arranged, measured, and repeatedly adjusted. But this new clarity had a human meaning as well. A worker placing V-shaped magnets on flywheels was not building a whole car. He was performing a fragment of the car's construction. The system gained power by narrowing the task. That narrowing would later become one of the defining tensions of Fordism: greater output through simpler, repeated motions, and less control for the worker over the larger craft of the job. In April 1913, that tension was already present, even if the full consequences had not yet unfolded. The magneto line promised speed and order. It also pointed toward repetition and pacing. Once work moved from person to person, the individual worker's rhythm began to matter less than the rhythm of the line. At first, that rhythm was still crude and manual. But the principle had been demonstrated. If motion could coordinate the assembly of a magneto, motion might coordinate the assembly of much more. That is why this small component deserves its place near the center of the story. It prevents the assembly line from becoming a myth of sudden perfection. It reminds us that the famous system was built through trials, adjustments, and partial successes. It began with a part small enough to push along by hand, but important enough to prove that production could be reorganized around movement. From there, the question became unavoidable. Could the same logic be extended beyond the flywheel magneto? Could the moving workpiece grow from a component into a chassis? Could Highland Park take the crude success of April 1913 and apply it to the heavy frame of the automobile itself, with axles, engines, wheels, and bodies waiting in sequence? The Magneto line had shown that work could move. Now Ford had to discover whether a car could. The Magneto line had shown that work could move, but a flywheel magneto was still a manageable object. It could be pushed from one worker to the next. It could be handled, adjusted, and advanced by human force in a way that still belonged partly to the older workshop world. A Model T chassis was different. The chassis was the heavy foundation of the car. It was the frame on which the rest of the automobile would gather: axles, gas tank, engine, dashboard, wheels, radiator, and eventually the body. If Ford could make the chassis move through assembly, then the moving line idea would no longer be confined to a small component. It would begin to organize the car itself. This was the essential step at Highland Park during 1913 and 1914. The experiment had to grow from a small part into a moving vehicle. And that growth was not smooth, clean, or instantly mechanical. The famous image of a chain-driven line, with each worker waiting at a fixed point as the car came past, can make the change seem sudden. But the evidence from Highland Park points to a more practical, transitional process. At first, the moving chassis line could still look crude. A 1913 assembly scene at Highland Park might show workers pushing or pulling vehicles between stations. The car did not yet glide through the plant, as if the factory itself had become a single machine. Men still supplied much of the motion. The line was not yet fully automatic. It was a trial in arranging heavy work so that the object advanced through a sequence, even when that advancement depended on hands, shoulders, ropes, or simple mechanical aids. One especially revealing detail is the chain hoist. In a 1913 Highland Park scene, a chain hoist lowered an engine onto a Model T chassis. That image captures the moment better than any polished legend could. The engine was too heavy to treat like a magneto part. It could not simply be passed down a bench. It had to be lifted, suspended, guided, and set into place. The chassis beneath it had to be brought into position. The work had to be timed well enough that one large object could meet another large object at the right place in the factory. This is where the assembly line began to become something larger than a moving bench. The challenge was not only to divide tasks, it was to move mass. A Model T was not assembled from ideas alone. It was assembled from steel, castings, wheels, tanks, radiators, and bodies. Each one had weight. Each one occupied space. Each one had to arrive at the proper point in the proper order. When Ford expanded the moving line idea from magneto assembly to chassis assembly, the company was not simply copying the small experiment at a larger scale. It was discovering what movement meant when the workpiece was the car. That distinction matters. A small component line could prove that repeated motions and moving work might save time. A chassis line had to prove that an entire factory could be reorganized around flow. If the chassis waited too long for an engine, the line slowed. If wheels arrived too early, they cluttered the floor. If workers had to search for parts, the motion broke down. If the car had to be shoved awkwardly from place to place, the system was still only partly formed. Highland Park in 1913 was therefore not a finished monument to efficiency. It was a place of experiments. The plant's open spaces, its scale, and its capacity for organized movement made those experiments possible. But the system still had to be learned in practice. Ford's people had to find out how to arrange stations, how to bring parts to the work, how to use simple mechanical devices, and how to reduce the delays that had been accepted under older methods of assembly. In the older station method, work gathered around the car. A group might assemble a large portion of the vehicle in one place, with parts and tools brought as needed. This gave workers and teams more room to control the pace of the job, but it also created waiting, walking, lifting, and interruption. The car stayed still while labor and materials moved toward it. The moving chassis experiment reversed that logic. Now the chassis became the traveler. The frame advanced, and the factory had to be arranged around its path. Each stop became a point where a limited task could be performed. The worker did not follow the whole car from beginning to end. The worker waited for the car to arrive. The job narrowed. The motion widened. This is one of the quiet revolutions of Highland Park. The product became the organizing object. The chassis pulled the system into shape. At first, that pull was literal. Workers pushed or pulled vehicles between stations. They helped impose motion on work that had once remained fixed. These rough movements were not failures of the assembly line idea.
They were part of its development.
Before the chain could control the pace, before the chassis could move with a regular mechanical rhythm, Ford had to establish the deeper principle that the car should proceed through assembly rather than sit in place. The chain hoist, lowering the engine, helps us see the problem clearly. The engine was one of the major moments in the building of a Model T. To install it efficiently, Highland Park had to coordinate the arriving chassis, the suspended engine, the workers guiding the placement, and the next step in the sequence. The operation depended on more than speed. It depended on position. It depended on order. It depended on the reduction of wasted movement. In that sense, the chassis line was not just a faster way to build a car. It was a new way to think about the factory. The earlier magneto experiment had been convincing because it made wasted motion visible. Instead of one worker doing many steps around a single part, many workers performed narrower steps as the part moved. With the chassis, the same principle became harder and more consequential. The automobile's frame could carry the logic of the entire plant. As it moved, it required axles to be ready, tanks to be ready, engines to be ready, wheels to be ready, radiators to be ready, and bodies to be ready. Each of these requirements pushed Highland Park toward a more integrated system. The moving line was not just the track or the chain. It was also the delivery of parts to the right place. It was the design of tasks small enough to repeat. It was the placement of workers so that they no longer had to roam the plant to find the next operation. It was the gradual tightening of time. And because it tightened time, it also began to change labor. Even in this transitional stage, before the fully developed chain-driven chassis line of early 1914, the direction was clear. The worker's job was becoming more specialized. Instead of building up knowledge across many parts of the car, the worker might repeat one operation again and again as vehicles passed through the station. The factory's efficiency came from narrowing the task and multiplying the repetition. That narrowing would later become one of the defining tensions of Ford's system. The same method that helped make the Model T easier to produce also made the work more monotonous and more tightly paced. But in 1913, the practical problem came first. Could Highland Park move a chassis through assembly with enough regularity to make the idea worth expanding? The answer was beginning to emerge. Ford expanded the moving line idea from component assembly to chassis assembly through a series of practical adjustments during 1913 and 1914. This was not the sudden arrival of a perfect invention. It was a sequence, a small moving component line, a rougher movement of vehicles between stations, the use of hoists and other aids for heavy parts, and then the gradual development of a more controlled chassis flow. The system was taking shape because the plant kept forcing the same question: how can the work move more continuously? The importance of the chassis is that it made the answer visible at full scale. A magneto could prove the principle, but the chassis could prove the future. If the chassis moved, the whole automobile could be broken into a sequence. If the sequence worked, production could grow beyond what station assembly allowed. If production grew, the Model T could become not just a successful car, but the object around which a new form of industrial work was organized. By the end of this transitional period, Highland Park was no longer simply experimenting with moving small parts. It was learning to move the car itself. The roughness of the 1913 scenes is part of their value. Workers pushing and pulling vehicles, an engine descending from a chain hoist, a chassis waiting to receive the next major piece. These details show the assembly line before it became an icon. They show invention as adjustment, not magic. And as the chassis began to move, Ford Motor Company also began to present its achievement more confidently. The factory was no longer only a place where an experiment had succeeded on a component. It was becoming a place where the scale of automobile production could be demonstrated. The movement of the chassis had opened the way for a more public claim that Highland Park was not merely building cars faster, but building a new kind of industrial order. That claim would soon gather around a date in 1913, and around the first automobile moving assembly line operation Ford would identify at Highland Park. The story was moving from workshop trial to factory demonstration. The chassis had begun to carry not only the parts of a Model T, but the weight of Ford's larger system. The chassis had begun to carry more than mechanical weight. By the autumn of 1913, it was carrying a claim about what Highland Park had become. Ford Motor Company would identify October 1913 as the month of the first automobile moving assembly line operation at Highland Park. That date matters. It gives shape to a process that otherwise looks scattered across shop floors, departments, and small adjustments. It marks the moment when the moving line idea, already tested on a Model T component and then extended into heavier assembly work, could be named as something larger, not only a production trick, but an automobile system. But the date should be handled carefully. October 1913 was not a lightning strike. It was not the instant when a finished modern assembly line appeared, complete and inevitable, inside the Crystal Palace. The story was messier, more mechanical, and more interesting than that. By then, Highland Park had already been experimenting with movement. In April of that year, workers had used a crude moving assembly line for the Model T flywheel magneto. They placed V-shaped magnets on flywheels and pushed the workpiece along to the next worker. It was a small part, but it proved a large principle. The product did not have to remain still while workers gathered around it. The work could be arranged so the object moved through a sequence. Then came the more difficult question of the chassis. A chassis was not a flywheel magneto. It was the foundation of the car, the structure that would receive axles, engine, dashboard, wheels, radiator, and body. Moving it through assembly meant coordinating larger parts, heavier loads, and more people. A 1913 Highland Park assembly scene could still look crude by later standards. Workers might push or pull vehicles between stations, while a chain hoist lowered an engine onto a chassis. The famous image of a perfectly timed, chain-driven line was still emerging. The factory was still learning how to make motion reliable. That is why October 1913 sits in the middle of the story, rather than at the beginning. Ford's claim gives us a point of recognition, but the invention itself had been forming through trials. The magneto line showed that small work could move. The chassis experiments showed that heavier work could be broken into stations. The October automobile moving assembly line operation drew those lessons closer to the whole car. To understand why Ford wanted a date like this, we have to look not only at mechanics, but at publicity. Highland Park was becoming a demonstration of scale. Ford was not merely changing how cars were assembled, it was showing the public that the company could produce automobiles at a pace that seemed to belong to a new industrial age. One striking example came just before October. In August 1913, Ford staged a promotional image showing 1,000 Model T chassis. The image represented the production of a single 9-hour shift. The point was not subtle. 1,000 chassis in one working shift was a visual argument. It turned factory output into a spectacle. Instead of asking the public to imagine production totals from a ledger, Ford arranged the evidence in physical form. Here were the chassis. Here was the volume. Here was what Highland Park could do. The August image is important because it shows that Ford was already communicating scale before the October claim took its place in the company's assembly line history. The public story and the factory story were moving together. Inside Highland Park, managers and workers were experimenting with the sequence of tasks, the handling of material, and the movement of the car. Outside the plant, Ford was shaping the meaning of that activity. The company wanted people to see not just a car, but a production system. This was essential to the Model T's larger role. The car had been introduced years earlier, and Ford had already made it the center of an ambitious manufacturing strategy. But the scale now being pursued at Highland Park was different. It depended on more than a larger building. It depended on a way of organizing human motion, parts, machines, and time. The plant's glass-filled spaces, its open floors, and its reinforced structure had made new forms of coordination possible. The moving assembly line gave that coordination a visible rhythm. Still, the word first can mislead if it is treated too simply. Ford Motor Company did not invent the automobile. It did not invent every principle of assembly. Earlier manufacturers had pursued mass markets, and other industries had long used forms of divided labor and flow. Even within Ford, the moving assembly line was not born fully developed in one department on one morning. It was assembled from many decisions, standardizing parts, subdividing work, arranging tools, delivering material, and learning how to move the product without stopping production. October 1913 matters because it marks a threshold. Before it, the moving line idea at Highland Park could be understood as a set of experiments, a magneto line here, a moving chassis there, a crude arrangement of workers pushing or pulling the car from station to station. After it, the idea could be understood as an automobile production method. The experiment was becoming an industrial demonstration. And demonstrations have power. They persuade people that a system is real. They persuade managers that further investment is justified. They persuade competitors that something important has changed. They persuade the public that a company has mastered not only a product, but a process. In this sense, the August image of 1,000 chassis and the October assembly line claim belong together. One speaks in pictures. The other speaks in institutional memory. The image says, "Look at the output of Highland Park." The date says, "Here's when the automobile moving assembly line became part of Ford's story." Neither one should be taken as the whole truth by itself. Together, they show a company moving from internal experiment toward public confidence. There is also a human side hidden inside these milestones. 1,000 chassis in a 9-hour shift meant 1,000 repetitions multiplied across many stations. It meant workers performing narrower tasks inside a more carefully ordered flow. The scale that looked so impressive in a promotional image was built out of repeated motions on the factory floor. Every gain in output required a closer relationship between the movement of the product and the movement of the worker. That relationship was still changing in late 1913. The line was not yet the fully developed symbol it would soon become. By early 1914, Ford would have a chain-driven chassis line operating at Highland Park. That development would sharpen the factory's rhythm. A chain would not merely move a car, it would help set the pace of labor. The worker's task would be fitted more tightly to the movement of the workpiece. For now, October 1913 stands as a hinge. It does not erase the experiments that came before it. It does not contain all the refinements that followed. Its importance lies in the transition it marks. At Highland Park, the moving assembly line was no longer just a promising method for a small component, and no longer only a rough solution for shifting a chassis through the shop. It was becoming the organizing principle of automobile production. The factory had found a way to turn motion into output, and output into proof. What remained was to make that motion steadier, more mechanical, and more demanding. Once the chain entered the story, the question would no longer be simply whether the car could move through the factory. It would be who, or what, controlled the pace. Once the chain entered the story, motion at Highland Park became less improvised and more exacting. The earlier experiments had shown that a chassis could be pushed, pulled, shifted, and advanced through the factory. They had shown that a car did not have to remain fixed while workers gathered around it. But by early 1914, Ford had moved closer to a different kind of movement, a chain-driven chassis line where the workpiece itself advanced according to a mechanical rhythm. The chain is an easy object to misunderstand. It can look like the invention. It can seem, in memory, as if Ford's breakthrough was simply to attach a chassis to a moving chain and let the rest follow. But the chain was not magic, and it was not alone. It mattered because it joined several ideas into one visible mechanism. Standardized parts had to arrive in usable condition. Tasks had to be divided so that each worker could complete a particular operation before the chassis moved too far away. Tools, materials, and men had to be arranged in the path of the work. The chain gave this larger system a pulse. At Highland Park, that pulse changed the meaning of factory time. Before the moving line became the central organizing principle, automobile assembly still retained something of the older station method. A car, or a major portion of a car, could remain in one place while groups of workers performed a range of operations around it. The work might still be subdivided, and the company was already pursuing speed and standardization, but the stationary car gave the job a different rhythm. A team could gather, adjust, wait, reach, and solve problems at the station. The pace came from supervision, skill, habit, and production pressure, but it was not yet embodied so completely in the moving object itself. The chain-driven chassis line narrowed that space. It made the movement of the car the worker's clock. A chassis moving past a worker did not ask whether the worker was ready in the old conversational sense. It arrived. It presented a task. Then it moved on. The job had to be scaled to that motion. If a worker's operation took too long, the line exposed it. If materials were not close enough, the delay became visible. If a tool was misplaced, the lost seconds belonged not just to one man, but to the flow of the line. The moving chassis turned scattered inefficiencies into interruptions of a system. That is why the chain should be understood as a symbol of coordination, not merely as a device. It connected labor to timing. It connected timing to material delivery. It connected material delivery to the subdivision of work. And it turned the factory floor into a place where motion itself could be managed. Ford's achievement at Highland Park was not that no one had ever imagined work moving before. Earlier industries and earlier automobile makers had pursued assembly principles and mass markets. Ransom E. Olds had pursued a mass market with the curved dash Oldsmobile in 1901. Ford's significance lay in refinement and integration. At Highland Park, the moving workpiece became part of a larger production order, interchangeable parts, dedicated machinery, semi-skilled labor, and a standardized product designed to be built in volume. Later, this combination would be associated with Fordism, the mass production of standardized goods on a moving assembly line. But in early 1914, this was not yet an abstract term. It was a daily experience in Highland Park, Michigan, just outside Detroit. The Model T chassis moved, and men stood along its path. The work became narrower. Instead of following a whole car through many stages, a worker might repeat one operation again and again. Tighten a part. Fit a part. Attach a part. Prepare for the next chassis. Then do it again. The line did not require every worker to understand the full automobile in the same way that a skilled craft worker or a broad assembly team might have understood it. It required the worker to master a smaller task within a larger sequence. This was one of the reasons the system could expand output so dramatically. Narrow tasks could be taught more quickly. Motions could be simplified. The plant could assign work in smaller units and search for ways to reduce wasted movement. In a factory built for volume, that mattered. Every saved motion, repeated across hundreds and then thousands of cars, became part of the economics of the Model T. Yet the same feature that made the line powerful also made it troubling. When work is divided into smaller and smaller tasks, the worker may become more efficient within that task. But the worker also gives up a portion of control. The job no longer belongs to the person in the same way. The sequence belongs to the system. The pace belongs increasingly to the line. Ho ho ho. The worker's knowledge is still necessary, but it is channeled into a smaller space, measured against the regular arrival of the next chassis. This is the labor question at the center of the Highland Park story. The moving assembly line was not only a way to make cars, it was a way to organize human effort. It changed where authority lived on the factory floor. In the older image of assembly, workers moved around the car. In the new image, the car moved past the workers. That reversal sounds simple, but it altered the balance between human judgment and mechanical timing. To management, the chain promised order. It helped make production predictable. It reduced the need for workers to walk long distances for materials or to wait for the next stage of work. It allowed supervisors and engineers to see the process as a continuous flow, with each operation arranged in relation to the one before and the one after. In a plant like Highland Park, where architecture, light, machinery, and floor organization had already been shaped around high-volume production, the chain made the factory's purpose more visible. To workers, the same order could feel like pressure. The line did not merely organize tasks, it disciplined bodies. It asked for repetition at a pace not fully chosen by the person doing the work. It made a factory day less like a series of varied operations and more like a sequence of repeated motions. That did not mean the work was easy. Repetition can be exhausting precisely because it is narrow, because the mind and body are held to the same action over and over, and because the room for variation shrinks. The evidence of worker dissatisfaction would become hard to ignore. Ford workers disliked the repetitive new assembly line discipline enough that labor turnover in late 1913 is reported by the Henry Ford as roughly 380%, with another Henry Ford article giving about 370%. Those figures belong to the wider story of wages, control, and the $5 day, but the roots of the problem were already visible in the rhythm of the line. The new system could produce astonishing output, but it also made the job harder to endure for many of the people inside it. That tension is important because it prevents the assembly line from becoming only a story of mechanical triumph. The chain-driven chassis line helped make the Model T cheaper to build. It helped show how standardized production could bring a complex machine within reach of far more households. It helped turn Highland Park into a model watched by other manufacturers. But the same chain also raised a question that would follow industrial work through the 20th century. If efficiency depends on controlling the movement of the job, how much control remains with the worker? At Highland Park, the answer was being worked out not in theory, but in the daily passage of chassis after chassis. The chain carried each frame forward. Parts waited along the route. Workers stood in position. The Model T accumulated itself in motion, not as one complete act, but as many small acts arranged in time. By early 1914, the line had become more than an experiment and more than a claim. It was becoming a route through the factory. To understand what that meant, we have to follow the car through that route with more care, from the frame at the beginning, through axles, gas tanks, engines, dashboards, wheels, radiators, and finally bodies. The rhythm of the chain becomes clearer when we watch what it carried and where it carried it across the floor of Highland Park. By early 1914, the moving line at Highland Park was no longer just a principle. It had a geography. The chain did not simply pull a chassis through empty space. It carried the beginning of a Model T along a planned route, past people, parts, platforms, and delivery points arranged so that the car could gather itself, piece by piece. One of the clearest ways to see that route is through Building H at the Highland Park Plant. The Henry Ford describes chassis assembly there as moving from south to north. That directional detail matters because it turns the assembly line from an abstract invention into a path across a real factory floor. The car did not appear all at once. It traveled. It entered the line as a frame, and as it moved north, it became more complete. At the start of the route were the frames. A Model T chassis began as the structural base on which the rest of the automobile would be built. In earlier methods of production, that frame might have remained in one place while workers came to it with parts, tools, and decisions. At Highland Park, the logic was being reversed. The frame moved, and the work was organized around its movement. That reversal is easy to state, but difficult to overstate. Once the frame was in motion, every later task had to be positioned in relation to it. The line required more than workers with skill. It required the right parts to appear at the right point in the right order. A delay in one place could affect the rhythm of the whole route. A missing part was no longer a local inconvenience. It was an interruption in flow. From the frame, the sequence moved to the axles. The axles gave the chassis the basis for movement, but in the factory, they also marked a stage in the car's accumulation. The Model T was still far from complete, yet it was no longer merely a metal structure. It was becoming a rolling object, able to receive the next systems in order. The line made that order visible. Each operation depended on the last one being finished enough for the next worker to do a narrow, repeatable job. Then came the gas tank. Like the frame and axles, it was part of a sequence that had to make sense in space as well as in engineering. The tank could not be installed after every other part had crowded the work area. The line enforced a kind of practical logic, build from what must support, hold, connect, and carry, toward what can be added later. This was not craftsmanship in the older sense of one worker or one team shaping the whole vehicle. It was choreography. The engine came next in the sequence described for chassis assembly. Earlier scenes at Highland Park had shown how rough this transition could be. In a 1913 assembly scene, workers still pushed or pulled vehicles between stations, and a chain hoist lowered an engine onto a chassis. That image belongs to the transitional moment before the line became fully settled. By early 1914, the problem remained the same, but the organization around it was changing. A heavy, central component had to meet the moving chassis at the proper moment. The engine was not just another part. It was the heart of the car's power. Installing it required coordination between machinery, workers, and the moving frame beneath it. The significance of the line was not that weight disappeared. Engines were still heavy. Parts still had mass. Workers still had to guide, fasten, and fit. The change was that the factory increasingly planned where each burden would be met. The workpiece came to the work, and the work had already been divided into stations. After the engine came the dashboard. In the language of assembly, the dashboard was another step in turning a chassis into something recognizably close to a car. It belonged to the driver's space, the area where control would eventually be gathered. But on the Highland Park line, even this became part of the same industrial rhythm. It arrived not as a finishing flourish, but as a scheduled operation on a route running south to north through Building H. Then came the wheels. Here the moving line depended not only on the motion of the chassis, but also on the movement of parts toward the chassis. In 1914, wheels were conveyed to a platform and slid down ramps. That detail is small, but it opens up the factory. The assembly line was not just one line. It was fed by other movements. Parts traveled toward it from above, beside it, and along auxiliary paths. The car moved forward, but the whole building was in motion around it. The ramp is an important image because it shows the simplicity and force of Ford's system. Not every improvement had to be a dramatic new machine. A platform, a conveyor, and a ramp could solve a timing problem. If wheels were needed at a certain point along the chassis route, then the factory had to bring the wheels there in a steady, predictable way. Sliding them down ramps reduced carrying, shortened reaching, and helped keep the work aligned with the pace of the line. Radiators followed in the sequence, and they too were conveyed to a platform and slid down ramps in 1914. Like the wheels, radiators arrived as part of the wider material flow feeding the main chassis line. The Model T accumulated parts not because workers searched the building for what they needed, but because the building delivered parts to the places where they were needed. The intelligence of the system was partly in this arrangement. The path of the chassis and the paths of components had to meet. The radiator also changed the appearance of the vehicle. With wheels and radiator in place, the chassis was no longer a bare mechanical base. It began to resemble the front profile of the Model T that the public would know. Yet even here, the factory's method kept the focus on sequence rather than drama. No single station made the car complete. Each station made the next station possible. Finally came the bodies. The body turned the moving chassis into the familiar shape of an automobile. It gave the mechanical platform its passenger space and outward form. But by the time the body was added, much of the Model T's identity had already been assembled underneath. Frame, axles, gas tank, engine, dashboard, wheels, and radiator had each joined the moving object in order. The body was not the beginning of the car. It was the late, visible proof of everything that had already been organized along the line. Following this route through Building H helps explain why Highland Park became so influential. The moving assembly line was not simply a chain dragging metal across a floor. It was an arrangement of time, direction, and supply. South to north, the chassis passed through a sequence. Along that sequence, the factory reduced wandering, waiting, and improvisation. It replaced them with repeated motions, staged materials, and a route that made each task smaller than the whole automobile. This is also where the human meaning of the line becomes more concrete. A worker did not need to understand or assemble an entire Model T to contribute to its production. The system asked for something narrower, one task performed at the correct moment as the work arrived. That narrowed task could make production faster, but it also narrowed the worker's relationship to the finished car. The Model T belonged to the line before it belonged to any single pair of hands. In Building H, the car was no longer built in one place. It accumulated. That word captures the change. The frame accumulated axles. The chassis accumulated a gas tank, an engine, a dashboard. It accumulated wheels and a radiator delivered by platforms and ramps. At the end, it accumulated a body. The factory did not wait for a complete car to be made by a stationary group. It created conditions in which completion emerged from movement. Once that route worked, the next question was scale. If one line could make the path of a Model T more orderly, more repeatable, and more predictable, then more lines could multiply the effect. By mid-1914, Highland Park was no longer proving only that a chassis could move through Building H. It was showing how parallel flow could turn a route through the factory into a new level of output. If Building H showed how a Model T could accumulate parts while moving, the middle of 1914 showed what happened when that movement was multiplied. One route through the factory was powerful. 3 routes running in parallel were something else. At Highland Park, the question was no longer whether the chassis line could work. It was whether the same pattern of motion, timing, and repetition could be spread across the floor until output itself began to take on a new scale. By mid-1914, Ford had 3 parallel chassis assembly lines operating at Highland Park. That detail is easy to pass over because the moving assembly line is often remembered as a single line, a clean symbol of modern industry. But at the plant itself, the breakthrough was not only a line. It was lines, side by side, coordinated, repeating the same basic sequence, each one turning the path of a Model T chassis into a measurable flow. The Henry Ford gives the scale plainly. By April 1914, workers could assemble more than 1,200 chassis in 8 hours on the parallel Highland Park chassis lines. It is a striking number, but its meaning depends on more than arithmetic. More than 1,200 chassis in a shift meant that the line had moved beyond demonstration. It meant that Ford had found a way to make movement repeatable, and then to make that repeatability compound. A chassis line did not produce such output simply because it moved. Movement by itself could create confusion as easily as efficiency. A frame pulled forward too early, an axle missing from its place, an engine not ready when the chassis arrived, a worker forced to search for a tool or wait for a part. Any of these could break the rhythm. The scale reached in April 1914 depended on something more disciplined than motion. It depended on flow. Flow meant that work had to arrive in a certain order. Frames first, then axles, then gas tanks, engines, dashboards, wheels, radiators, and bodies. It meant that material could not merely be stored somewhere in the building. It had to be delivered to the right point at the right time. It meant that workers were not wandering between tasks as a car sat in place. The task came to the worker, carried forward by the line, and the worker repeated one limited action within a larger sequence. This was the quiet power of parallelization. A single chassis line turned assembly into a chain of timed steps. 3 parallel chassis lines turned that chain into a production system with breadth. Instead of one stream of work moving through Highland Park, there were multiple streams. Each stream carried frames toward completion. Each required parts, people, tools, and timing. And each increased the plant's ability to turn the same standardized design into finished chassis again and again. The Model T mattered here because it was standardized enough for this kind of system. The line depended on parts that could be fitted with confidence, on jobs that could be divided into simple, repeated motions, and on a vehicle design that could pass through the same sequence over and over. Ford Motor Company had not invented the automobile, and it had not invented every principle of assembly work. But at Highland Park in 1913 and 1914, the company was fusing those principles into a system large enough to change what factory production looked like. The number from April 1914, more than 1,200 chassis in 8 hours, also tells us something about the changing experience of labor. To reach that pace, workers had to fit themselves into the rhythm of the line. The job became smaller in scope, but more exact in timing. One worker did not need to assemble a whole car. He needed to perform his portion of the work as the chassis arrived, then repeat it as the next chassis came, and the next. The skill of the old station system, where a team might remain with a vehicle through a broader set of operations, was being replaced by a different discipline, coordination with the moving workpiece. There is a temptation to see the 3 lines as a triumph of machinery alone. But the machinery was only one part of the story. The chain-driven line helped control movement. Conveyors, platforms, and ramps helped carry material toward the work. Specialized tools and standardized parts reduced variation. Managers and engineers studied the sequence of operations, adjusting tasks so that one part of the process did not starve or block another. What emerged was not simply faster work, but balanced work. Line balance is a dry phrase for a very human problem. If one station took too long, the work behind it would wait. If one station finished too quickly, workers there might stand idle while the next chassis approached. To produce more than 1,200 chassis in an 8-hour period, Highland Park needed many small tasks to fit together with unusual precision. The line was not only a device for moving cars. It was a way of arranging time. And time, at Highland Park, was becoming a material almost as important as steel. Every unnecessary step mattered. Every search for a part mattered. Every pause in which a chassis sat unfinished mattered. The old waste of movement, workers walking to parts, teams gathering around a stationary car, work waiting for the next operation was being attacked by redesigning the flow itself.
The factory was learning to remove distance from the job. Parts moved. Chassis moved.
Workers, increasingly, stayed in place. That was one of the central transformations of the assembly line. It did not merely speed up the making of a car. It changed where effort was spent. In earlier station assembly, much of the work included positioning, fetching, adjusting, and coordinating among people around a fixed object. On the moving line, the system tried to absorb those activities into the layout of the plant. The path had been planned before the worker touched the part. The next operation had been anticipated before the chassis arrived. The line made preparation invisible by embedding it in the factory's design. 3 parallel chassis lines made that design visible at scale. Imagine the effect not as spectacle, but as repetition, frame after frame entering the sequence, axles being attached, gas tanks added, engines lowered into place, dashboards fitted, wheels and radiators meeting the line, bodies completing the transformation. The same order again and again across more than one line at once. Not a single craftsman finishing a single automobile, but many workers contributing small actions to many automobiles in motion. This is why the April 1914 output matters. More than 1,200 chassis in 8 hours was not just a production record. It was evidence that the new factory rhythm could be sustained across a working day and across multiple lines. It showed that Highland Park had crossed from experimentation into industrial routine. The unusual had become repeatable. The repeatable had become scalable. But the achievement carried its contradiction inside it. The same system that allowed Ford to raise output narrowed the worker's task. The same flow that reduced delay also reduced individual control over pace. The same repetition that made production predictable could make the work feel monotonous and relentless. The line solved one problem by creating another. It made the factory more efficient by asking human beings to adapt themselves to a machine-like rhythm. That contradiction did not erase the power of the system. It helps explain it. Ford's assembly line mattered because it reorganized production so thoroughly that the old measures began to look obsolete. Once 3 parallel lines could produce more than 1,200 chassis in 8 hours, the next question became unavoidable. How much time had actually been removed from the making of a Model T? The answer would become one of the most famous comparisons in industrial history, not because it was magic, but because it revealed what could happen when standardized parts, simple repeated motions, timed delivery, and a moving workpiece were joined into one system. By the time Highland Park could run 3 chassis lines in parallel, the factory had become a kind of measuring instrument. It measured distance in feet of moving work. It measured labor in repeated motions. It measured organization in whether the right part arrived at the right place before the chassis passed. And most famously, it measured time. The comparison that entered industrial history was stark. Under the older station method, assembling a Model T took about 12.5 man-hours. With the moving assembly line, that figure fell to a little over 1.5 man-hours, often summarized as 93 minutes. The number is so dramatic that it can sound like a trick, or like a machine suddenly appeared and did the work by itself. But that is not what happened at Highland Park. The reduction came from a system, and the system worked because many smaller changes were made to serve one another. The first condition was standardization. A moving line cannot pause while a worker files a part to fit, searches for the right bolt, or decides how to solve a small mismatch. The Model T had to be built from parts that were predictable enough to meet one another again and again. Interchangeable parts were not Ford's private invention, and neither was the general idea of subdividing work. But at Highland Park, these ideas were pressed into a new relationship with movement. Standardized parts made repeated assembly possible. Repeated assembly made timing possible. Timing made the moving workpiece practical. The second condition was the narrowing of the job. In station assembly, a group of workers might remain with a larger portion of the car for a longer period. They had to know more of the whole. Their work contained more variation, more judgment, and more interruption. On the moving line, the work was broken into simpler operations. One worker did not build a car. One worker performed a task on a car that was passing by. Then another chassis came. Then another. The time saved in this arrangement did not come from making each human body faster in some miraculous way. It came from removing the gaps between tasks, removing unnecessary walking, removing waiting, and removing the need to shift attention from one kind of work to another. That point matters because the old phrase, 93 minutes, can hide the physical reality behind it. At Highland Park, the saving was built out of thousands of small denials. No long search for a tool, no carrying parts across the floor when the part could be delivered to the worker, no letting a nearly finished chassis sit idle while another operation caught up. The line forced the question again and again. If a worker needs this part at this moment, why is it not already there? If the chassis must receive this component next, why is the next station not arranged for that exact action? If one step takes longer than the others, how can the work be divided so that the whole line continues to move? This was the real breakthrough. Not the chain alone, not the magneto experiment alone, not building H alone, not even the 3 parallel chassis lines alone. Ford's achievement at Highland Park was the integration of methods into one disciplined flow. The moving assembly line turned time into a design problem. The factory no longer asked simply how many workers could be gathered around a vehicle. It asked how work, parts, tools, and motion could be arranged so that the car gathered itself in a planned sequence. The earlier chapters followed that sequence as a physical path: frames, axles, gas tanks, engines, dashboards, wheels, radiators, and bodies. But the 93-minute figure lets us see the same path as a compression of time. Each station held only a small piece of the old assembly process. Each piece had to be fitted to the pace of the line. If one operation fell behind, the motion that created efficiency could become a source of pressure. The system was powerful because it made delay visible. It was harsh for the same reason. The line also changed what counted as skill. The older factory did not disappear overnight, and skilled labor remained important in many parts of manufacturing. But the famous chassis line pointed toward a different kind of production worker, semi-skilled, trained for a narrow task, and placed within a process designed by managers and engineers. The worker's knowledge was no longer chiefly the knowledge of the whole vehicle. It was the practiced certainty of a repeated movement. Tighten this. Place that. Attach this part before the chassis moves beyond reach. Do it again when the next one arrives. In that sense, the time reduction was also a transfer of control. Under station assembly, the pace of work could be irregular. A team might speed up, slow down, solve problems, or organize its own immediate rhythm around the object in front of it. On the moving line, the pace became external. The workpiece moved. The worker adapted. The line did not merely carry the car, it carried time through the building. It told each person when the task began and when the opportunity to complete it was gone. This is why the famous number should be heard with 2 meanings at once. 93 minutes meant extraordinary industrial efficiency. It meant that Highland Park could produce Model Ts at a scale that made older methods seem slow and costly. It helps explain why, by April 1914, workers on the parallel chassis lines could assemble more than 1,200 chassis in 8 hours. It helps explain why the Highland Park system became one of the central examples in the history of modern production. But 93 minutes also meant that human work had been redefined. The system saved time by narrowing the worker's task. It created output by limiting variation. It made production more predictable by making labor more repetitive. What looked, from a distance, like smooth mechanical progress could feel, on the floor, like a relentless succession of identical demands. That contradiction was not an accidental side effect. It was built into the achievement. The same simplification that allowed a worker to learn a task quickly also made the task monotonous. The same timing that allowed the factory to produce at unprecedented speed also reduced the worker's control over the pace. The same standardization that helped make the Model T easier to assemble also made the day's labor more uniform. This is the quiet tension inside the celebrated comparison. 12.5 man-hours belonged to a world in which the car remained longer in one place and labor surrounded it with more flexible effort. 93 minutes belonged to a world in which the car moved through labor, collecting small operations from workers whose motions had been separated, timed, and repeated. The difference was not only numerical, it was social. It changed the relationship between the person and the product. At Highland Park, the Model T became less a vehicle assembled by a group and more the result of a coordinated system. The worker still mattered. Without hands, attention, and endurance, the line could not function. But the worker now mattered inside a structure that had already decided much of the job in advance. The path of the chassis, the placement of parts, the rhythm of delivery, and the division of labor all shaped what the worker could do. That was the machine that changed work forever. Not just a chain pulling a chassis, but an entire arrangement that made speed possible by organizing people, parts, and movement around a single flow. The reward for that organization would soon be seen beyond Highland Park's walls. Less time in assembly meant lower unit costs. Lower costs opened the way to lower prices. And as the factory compressed the time required to build the Model T, the effects began to travel outward, from the line itself into the lives of buyers who could now imagine an automobile not as a luxury, but as something within reach. The speed inside Highland Park did not remain an internal factory matter. Once time was removed from assembly, it began to reappear somewhere else, in the price of the car, in the expectations of buyers, and in the changing meaning of automobile ownership in the United States. The moving line was a way of organizing work, but it was also a way of changing the market. It connected the motion of parts inside Building H to the decision a family might make far from Highland Park, whether a car was still a rich person's machine or whether it could become part of ordinary life. That connection was not automatic, and it was not sentimental. It depended on arithmetic. If standardized parts could be made in large quantities, if the work of assembly could be divided into narrow, repeated tasks, if material could arrive at the right moment, and if the chassis could move instead of waiting in place, then each Model T required less time to assemble. Less time meant lower labor input per unit. Higher volume meant fixed costs could be spread over more cars. The factory system did not make automobiles cheap by wishing them into reach. It lowered unit cost by redesigning the relationship between people, parts, machines, and motion. This is where the Model T becomes more than the object moving down the line. It becomes evidence of a wider social change. Ford Motor Company produced more than 15 million Model Ts during the model's production run from 1908 to 1927. That number matters because it shows that the car was not only a technical product, it became a mass product. The Model T was repeated, standardized, and sold in quantities that made it one of the defining manufactured objects of the early 20th century. At the beginning, however, the Model T was not yet the cheap car of memory. Source examples give its introductory price as $850. For many Americans, that was still a large sum. It was lower than some luxury automobiles, but it did not yet mean that the car had become an everyday purchase for the broad public. The automobile was still emerging from a world of expense, novelty, and mechanical uncertainty. It was useful, but it was also aspirational. By the middle of the 1920s, the picture had changed dramatically. Sources give a Model T price of about $260 by 1925. The exact comparisons depend on model, year, and body style, but the direction is unmistakable. Across the Model T's lifetime, the price fell sharply. That decline is one of the clearest consumer-facing results of Ford's production engineering. What had been introduced at $850 could, by the mid-1920s, be bought for roughly a third of that amount. The price drop did not come from one isolated improvement. It came from the same system that earlier chapters have traced inside Highland Park. Interchangeable parts made repetition possible. Repetition made specialized work routines possible. Specialized routines made the line easier to balance. The moving workpiece reduced wasted motion. Dedicated machinery supported volume. Factory layout shaped flow. The price on the sales side was tied to the organization of motion on the production side. The Henry Ford reports the scale of this transformation in output at Highland Park. The plant's production rose from about 200,000 Model Ts in 1913 to more than 820,000 in 1919. Those are not just impressive production figures. They are a measure of industrial confidence. In 1913, Ford was still moving from experiment to full system. Magneto work, chassis movement, crude scenes of workers pushing or pulling vehicles, and the emerging chain-driven line. By 1919, the Highland Park system had become a machine for output on a far larger scale. The increase from about 200,000 to more than 820,000 Model Ts also helps explain why the car could be priced differently. A factory making hundreds of thousands of standardized cars was not operating like a shop producing small batches for a limited clientele. It was building for a mass market. The plant was designed not only to make cars, but to make many of the same car, over and over, with enough regularity that cost, schedule, and supply could be controlled more tightly. This is one of the reasons the Model T is so closely associated with the democratization of the automobile. The word can be overused, and it should be handled carefully. Ford did not make a car available to every person. Even a lower-priced Model T still required money, maintenance, roads, fuel, and a buyer who could fit the car into household or business life. But the fall in price did help shift the automobile from a luxury product toward a mass consumer good for many American buyers. It widened the circle of people who could imagine ownership. That change mattered, especially in a country where distance shaped daily life. The United States contained cities, small towns, farms, and expanding suburbs. A lower-priced automobile could change how people thought about work, family visits, trade, and movement. The Model T was not simply a machine for transportation. It was a manufactured promise that movement itself could be purchased by more people than before. But the promise depended on standardization. The same features that made the car cheaper also made it less individual. Ford's production system worked because variation was limited and flow was protected. The Model T became affordable in part because the factory was built around repetition. The consumer gained access to a lower-priced automobile because the worker's day was increasingly organized around a narrower, repeated task. That is the central tension of the price story. The cheaper car looks from the outside like liberation. It means mobility, access, and participation in a new consumer world. But from inside the plant, the same process looks more controlled. A buyer saw the result of lower unit costs. A worker felt the method by which those costs were lowered. The Model T's price tag, then, was not only a number in a sales room. It was a compressed expression of industrial discipline. Highland Park made this connection visible. The glass-filled factory, the routed chassis, the timed delivery of parts, and the subdivided labor all pointed toward a single business result: build more cars with less wasted time at a cost that allowed the price to fall. In that sense, the price of the Model T was not separate from the assembly line. It was one of the assembly line's public forms. The customer did not need to see the chain, the ramps, the parts platforms, or the repeated motions to feel their effect. The effect appeared in affordability. This is why Ford's achievement became so influential. Other industries could look at Highland Park and see more than automobile production. They could see a model for organizing demand around volume. Standardize the product. Rationalize the work. Increase output. Lower unit costs. Expand the market. The logic later associated with Fordism was not only about making things quickly, it was about linking mass production to mass consumption. Yet this achievement left Ford with an unresolved problem. The factory could produce at extraordinary scale. The Model T could fall in price. Buyers could enter the automobile age in larger numbers. But the human beings on the line still had to endure the new rhythm that made this possible. The same system that helped lower the price also narrowed the job, tightened the pace, and reduced the workers' control over the work. From the consumer side, the Model T looked increasingly attainable. From the factory side, the work that built it was becoming difficult to keep staffed. From the buyer's side, the Model T told a story of access. A car that had once seemed beyond the reach of many American households was becoming more attainable as production rose and costs fell. But inside Highland Park, the same system told a different story. It was not a story of freedom on the open road. It was a story of narrowed motion, repeated hour after hour, under a pace increasingly set by the line itself. This is where the triumph of Ford production becomes harder to separate from its human cost. The moving assembly line had solved a manufacturing problem. It had shown that a car could be built not by gathering workers around a stationary object, but by moving the object through a carefully organized sequence of tasks. At Highland Park, frames, axles, gas tanks, engines, dashboards, wheels, radiators, and bodies could be brought into rhythm. By mid-1914, 3 parallel chassis lines could turn out more than 1,200 chassis in 8 hours. The factory had become a system of flow. But a system of flow also required people to fit into that flow. For the worker, the job was no longer defined by building up a large part of a car or following a task through many stages. It was increasingly defined by doing one small piece of work, then doing it again and again as the work moved past.
The line did not simply carry parts. It carried time. It made time visible. It made delay costly.
It made the worker's motion part of a larger mechanical rhythm. That change could raise output dramatically.
It could also make the job feel intolerable. The Henry Ford reports that
Labor turnover in late 1913 reached roughly 380%. Another Henry Ford article gives the figure as about 370%. The difference between those two figures matters less than the scale they both describe.
they are not small variations around a stable workforce.
They point to a factory that was having serious trouble holding on to the people it needed.
A turnover rate in that range
Means Ford was not merely replacing a few dissatisfied workers at the margins. It suggests that the workforce was cycling through at an astonishing pace. Men came in, tried the work, and left.
others had to be found.
The moving line had created an industrial machine capable of extraordinary production, but the human beings attached to that machine were not staying in place. The research does not let us reconstruct every worker's voice in detail.
It does not give us a complete record of each reason for leaving.
But it does show the central problem clearly enough. Ford workers disliked the repetitive new assembly line discipline. The jobs had become narrower, faster, and more closely paced. The line organized the worker as much as it organized the car.
That is the crucial distinction. The assembly line was not just a new layout.
It was a new form of factory discipline. Earlier in the Highland Park story, the movement of workpieces had appeared as a technical breakthrough. On the Magneto line in April 1913, workers placed V-shaped magnets on Model T flywheels and pushed the workpiece along to the next worker.
It was crude, but revealing.
A task could be broken into steps. A part could move from hand to hand.
Output could rise when the work itself traveled.
When that principle expanded to chassis assembly, the consequences became larger. A worker did not need to understand the whole automobile in the same way. He needed to perform his assigned motion correctly, quickly, and repeatedly. The line made training simpler in some respects because each job was narrower.
But it also made the day more monotonous.
What had once been a broader craft or station task became a slice of work measured against the movement of the chassis. The worker's control over pace declined. If the work arrived, the worker had to be ready. If the next chassis came forward, the task had to be complete. The line did not wait in the way a stationary job might.
It imposed sequence.
It reduced idle space between tasks. It transformed the factory from a collection of work areas into a coordinated stream. This was the brilliance of the system, and also its burden. At Highland Park, the physical plant itself helped support this order. The factory designed by Albert Kahn, the glass-filled complex later nicknamed the Crystal Palace, had already been shaped around visibility, light, and floor organization. In earlier chapters, that architecture appeared as part of Ford's production achievement. Here, it also appears as part of the worker's experience. A factory built for organized flow was also a factory built for supervision and coordination. The clearer the movement of parts became, the clearer the movement of workers had to become as well. The new system depended on people accepting the line's discipline. But in late 1913, the turnover figures suggest that acceptance was far from guaranteed.
Ford could standardize parts.
It could refine the route of a chassis through Building H. It could convey wheels and radiators toward the line and slide them down ramps. It could arrange engines, dashboards, and bodies in a sequence that made assembly faster. But it could not simply standardize human endurance. It could not assume that workers would remain in jobs that stripped the work into repeated gestures and tied those gestures to a moving pace.
This was not a side issue.
It threatened the system from within. Mass production needs more than machines. It needs continuity. It needs workers who show up, learn the task, and remain long enough for the whole arrangement to function smoothly. High turnover disrupts that continuity. It forces hiring and replacement. It weakens the stability that a paced line requires. A moving assembly line can be engineered in steel, wood, belts, chains, platforms, and factory routes, but it still depends on bodies at each station.
The irony is sharp.
Ford had built a system that reduced the amount of labor time needed to assemble the Model T, yet the work that remained could be so repetitive and tightly controlled that workers walked away from it. Efficiency on paper did not automatically produce stability on the shop floor. The public story of Highland Park often centers on output, more cars, shorter assembly times, lower prices. Those achievements were real. But the turnover figures force another measurement into the story. They ask not only how fast a car could be assembled, but how long a person could tolerate the job of assembling it under the new conditions. The line changed the meaning of factory skill. It did not eliminate human labor. It reorganized it. It turned the worker into a specialist in a tiny portion of the whole. That specialization made the Model T cheaper to build. It also made the worker's day more constrained. The system gained power by reducing variation, and that reduction applied to motion, timing, and judgment. A man on the line did not have to decide the full sequence of assembly. The sequence had already been decided for him. He did not have to gather a wide range of parts. The system worked to bring parts to the proper place. He did not set the general rhythm of the job. The moving workpiece increasingly did that. What remained was execution, the right motion at the right moment, repeated across the shift. For management, that was order. For many workers, it was drudgery. This is why the late 1913 turnover figures sit at the center of the Ford story. They show that the assembly line's success created a new managerial problem. Ford had not only changed how automobiles were made, he had changed what had to be managed. The company now had to manage dissatisfaction produced by its own efficiency. The answer would not be to abandon the line. The line was too productive, too powerful, and too closely tied to the company's expanding ambitions. The Model T's price, output, and market reach all depended on the production system continuing to improve. Ford's challenge was different: how to make workers stay inside a form of labor many of them did not like. That challenge would soon reshape the public image of the Ford Motor Company. In January 1914, the company would make an announcement that seemed, at first glance, to answer the human problem with generosity. It would promise higher pay and a shorter working day. It would draw attention far beyond Highland Park, but the solution would carry its own discipline. The problem of workers who would not stay was about to lead Ford toward one of the most famous wage policies in American industrial history, and toward a deeper bargain between pay, productivity, and control. The problem Ford faced at the end of 1913 was not whether the line could produce. It could. Highland Park had already shown that a moving system of parts, men, tools, and timing could build the Model T at a pace earlier factory methods could not match. The harder question was whether workers would remain inside that system long enough for it to keep expanding. The answer Ford offered came early in the new year. On January 5, 1914, Ford Motor Company announced what would become one of the most famous wage policies in American industrial history, the $5 day. The announcement was made with Ford Vice President James Couzens, and it immediately changed the way people looked at Highland Park. Until then, the story of the plant had been largely a story of production. It was about lines, chains, parts, output, and the falling price of the Model T. Now the factory became the center of a different public drama. Ford was not only making cars faster, it was promising to pay workers more. The contrast was striking. Before the announcement, Ford's daily wage had been about $2.30 to 34 cents for a 9-hour day. The new plan promised $5 for an 8-hour day. In the language of the time, and in the memory of American labor history, that sounded almost simple: more money, fewer hours. A worker who had been giving the company 9 hours could now work 8. A worker who had been receiving a little over $2 a day could now be associated with a $5 day. It is easy to see why the announcement drew attention. At a moment when the new assembly line discipline had made Ford work difficult to endure, the company appeared to reverse the balance. The machine had narrowed the job. The wage seemed to enlarge the reward. The line had taken control of the pace. The $5 day seemed to compensate for that loss by making the job worth keeping. But the importance of the policy lies in the fact that both things were true at once. The $5 day was a labor milestone. It also became a management tool. For workers, the new wage made Ford jobs far more desirable. That mattered because the company had been facing an extraordinary turnover problem. Late in 1913, the Henry Ford reports labor turnover at roughly 380%, while another Henry Ford account gives the figure at about 370%. However one phrases the exact figure, the meaning is clear enough. The moving line could make workers productive, but it could not automatically make them stay. The new wage answered that problem with force.
It made a job at Highland Park stand out.
In a factory system where tasks could be repetitive and the pace could be unforgiving, the pay helped change the calculation. A worker might dislike the monotony. He might feel the pressure of the moving line. He might experience the job as a narrow place inside a vast system. But the promise of $5 a day made leaving more costly. The wage did not soften the line itself. It made endurance more attractive. That is why the January announcement belongs inside the assembly line story, not beside it. It was not simply a separate act of generosity added to a technical innovation.
It was part of the same industrial system that Highland Park was building.
The factory had reorganized motion, materials, and time. Now Ford was reorganizing the labor market around the factory. If the line required a stable workforce, then wages became one more mechanism of production. The shift to the 8-hour day also mattered. Earlier chapters in this story have followed the factory's effort to compress time. Less time to assemble a chassis, less time between operations, less wasted movement, less waiting for parts. The new wage policy placed a different kind of time at the center of public attention. The working day itself changed. 9 hours became 8. That shorter day was linked to the $5 figure, and together they helped define Ford as a company that was doing something dramatic, not only with machines, but with labor. Yet the public image could obscure the bargain underneath. The $5 day was not simply an unconditional wage increase. It was tied to company conditions. The money came with rules, expectations, and supervision. Ford did not merely decide to pay more and then step back from the lives of employees. The company connected the benefit to a broader program that looked beyond the factory floor. That is where the wage story becomes more complicated than the familiar legend allows. In popular memory, the $5 day is often remembered as a moment when Ford raised wages so that workers could share in the prosperity of mass production. There is truth in the milestone. The wage was remarkable. It helped make Ford employment desirable. It helped stabilize a workforce shaken by the pressure of repetitive assembly line labor. It gave the company a powerful public identity at a time when Highland Park was becoming a symbol of modern production. But higher pay and greater control arrived together. This combination was not accidental. The assembly line itself had already changed the workers' relation to the job. Under older station methods, the work could be broader and less tightly paced by a moving mechanism. At Highland Park, the movement of the workpiece increasingly governed the day. The worker did not simply make progress, he kept up. The line divided jobs into smaller motions and made those motions repeat with a new regularity. In that world, Ford needed not only hands at stations, but reliable bodies in place, day after day, hour after hour. The $5 day helped secure that reliability. It created an incentive strong enough to pull workers toward Highland Park and hold them there. It was a wage policy, but it also had the effect of disciplining the labor supply. The company had found a way to make an unpopular rhythm more acceptable without fundamentally changing the rhythm itself. This is one of the central tensions of Fordism, before the word itself became a shorthand for a whole industrial order. Mass production promised abundance. It lowered costs. It helped bring standardized goods within reach of more buyers. But inside the factory, it depended on close coordination and limited worker autonomy. The Ford worker received a better wage, but the system still asked him to submit to the pace and structure that made that wage possible. The announcement on January 5, 1914, therefore marks a turning point in the story, not because it replaced the assembly line, but because it revealed what the line required. Highland Park's machines and workflows could not stand alone. The factory needed a labor policy equal to its production policy. If parts had to arrive on time, workers had to arrive too. If the chassis had to move steadily from station to station, men had to remain available for each narrowed task. The $5 day was a way of fastening people more securely to a system built around motion. James Couzens's role in the announcement also reminds us that this was a company policy, not simply a personal gesture by Henry Ford. Ford Motor Company was becoming an institution with methods, departments, and administrative reach. Its genius, if that is the right word, was not only mechanical, it was organizational. The same company that arranged frames, axles, engines, dashboards, wheels, radiators, and bodies into a moving sequence now began arranging wages, hours, eligibility, and conduct into a social system around the worker. That social system would become increasingly important. The $5 figure drew the headlines, but the conditions attached to it would shape the lives of the men who sought the full benefit. To receive the promise of the new wage was not merely to stand at a place on the line and perform a task. It was to become visible to the company in a wider sense. Here the story begins to move beyond the factory gate. The discipline of Highland Park had started with time and motion inside the plant. But once the $5 day was tied to company expectations, Ford's interest in the worker did not end when the shift ended. The same industrial logic that had organized production so tightly began to reach into questions of home life, habits, housing, savings, and conduct. So the $5 day stands as both breakthrough and warning. It was a real labor milestone, and it helped answer a real crisis of turnover. It made Ford jobs famous and desirable. It gave workers a shorter day and the possibility of a much higher daily income than before. But it also joined wages to supervision. It showed that in the Ford system, generosity could be inseparable from control. The line had changed how work was done. The wage changed what workers were willing to endure. And now, behind the celebrated promise of $5 a day, Ford was preparing to define the kind of life a worker was expected to live in order to receive it. The promise of $5 a day did not stop at the pay window. That is the part of the Ford story that is easy to miss if the wage is treated only as a headline or only as an act of industrial generosity. At Highland Park, higher pay came wrapped inside a larger idea of management. Ford Motor Company was not only trying to keep workers on the line, it was trying to shape the conditions under which those workers lived, saved, behaved, and returned to work each day. The moving assembly line had already reorganized the factory floor. It had divided tasks into smaller motions. It had tied those motions to the pace of the workpiece. It had made output depend on timing, repetition, and the steady movement of parts through space. The $5 day extended that system in another direction. It suggested that the company's concern with efficiency did not end when a worker stepped outside the gate. This was where Ford's Sociological department entered the story. The name itself sounds almost academic, almost reform-minded. And in part, that was how Ford presented it. The department belonged to the company's welfare program, the side of Ford that claimed an interest in the well-being of its employees. It was connected to the profit-sharing conditions behind the $5 day. The wage was not simply handed out to every worker as an unconditional increase. It was tied to standards, and those standards had to be inspected. To receive the full benefits, a worker could be judged not only by what he did at his station, but by how he lived away from it. The Sociological department investigated home lives, habits, housing, savings, and conduct. Its agents looked beyond the immediate question of whether a worker could tighten a bolt, place a part, or keep pace with a line. They asked whether he was living in a way the company considered stable, responsible, and orderly. In this sense, Ford's welfare program had two faces. One face was the public one, a famous wage, a shorter workday, a company claiming that better paid workers could live better lives. That face mattered. The $5 day was a real milestone, and it helped make Ford jobs desirable at a moment when Highland Park badly needed a more stable workforce. But the second face was quieter and more intrusive. It was the face of supervision, classification, and investigation. The company's logic was not hard to see. A moving line depended on regularity. It needed men to arrive on time, stay through the shift, perform narrow tasks again and again, and return the next day. The line could not easily absorb constant absence, disorder, or turnover. If the factory was to run as a coordinated machine, then management wanted workers who could be made predictable. The Sociological department translated that desire into a program of social control. It made the workers' private life part of the company's industrial calculation. This was not simply a matter of sentiment. It was part of the same system that had made Highland Park so powerful. The glass-filled factory, the organized floors, the chain-driven chassis line, the subdivision of labor, the carefully timed material flow, and the wage policy all belonged to a wider structure. Ford's breakthrough was never only a machine. It was a method of coordination. And once coordination became the goal, the worker's body, time, habits, and household all began to look like parts of the same problem. Sources associate Dean Samuel Marquis with Ford's social welfare supervision, and his presence in the story helps show how Ford's program blended industrial management with moral oversight. Marquis was not a rival automaker. He was not a designer of the Model T. He was not part of the mechanical sequence of frames, axles, engines, wheels, radiators, and bodies moving through Highland Park. Yet his association with Ford's welfare supervision belongs in the assembly line story because the line had created a new kind of labor problem. It did not only require engineering, it required discipline. Ford's managers could redesign the path of a chassis through Building H. They could divide the work so that parts arrived in sequence. They could lower engines into place, slide radiators and wheels down ramps, and run parallel lines to multiply output. But the company also had to confront the human reaction to that work. The turnover figures from late 1913 showed how deep the problem had become. Workers did not naturally accept the pace and repetition of the new system. They left in great numbers. The $5 day was a response. The Sociological department helped define the terms of that response. The result was a bargain that still feels modern. Ford offered more money, but the workers surrendered more privacy. The company offered stability, but it also claimed authority over conduct. It presented itself as a benefactor while building a mechanism for inspection. The wage made the factory more attractive. The surveillance made the worker more visible. That visibility is important. Highland Park's architecture had already made work visible inside the plant. The Crystal Palace, with its glass and open industrial spaces, was part of a world in which production could be watched, arranged, and rationalized. The Sociological department carried a similar impulse beyond the production floor. If the factory made the job visible, the welfare program made the household visible. If the moving line measured labor in repeated motions, the department measured life and habits, savings, housing, and behavior. This does not mean that every worker experienced the program in the same way, or that the wage had no value. For many workers, the possibility of $5 a day was significant. Compared with the earlier wage of about $2.30 to 34 cents for a 9-hour day, the new policy represented a striking change. It helped draw attention to Ford from far beyond Highland Park. It helped answer a crisis of labor turnover. It also linked the 8-hour day to a new kind of industrial bargain. But the conditions matter because they change the meaning of the wage. Without them, the $5 day can look like a simple story of enlightenment. A manufacturer pays more, workers benefit, productivity rises. With them, the story becomes more complicated. The wage was not only a reward for labor, it was a lever. It encouraged workers to conform to a company-defined model of proper life. At this point in the episode, the rivalry has shifted. Earlier, it was possible to describe competition among automakers, or among production methods, or between the old station style of assembly and the new moving line. Ford had not invented the automobile. Ford had not invented every principle of mass production. But Highland Park brought those principles together with unusual force. It made the moving line a practical and public symbol of industrial power. Now the rivalry is different. It is between worker autonomy and managerial control. On one side stood the worker's claim to a life beyond the factory, a home, habits, choices, mistakes, savings, and private conduct not subject to corporate approval. On the other side stood a company that saw stability and discipline as necessary to its production system. Ford did not merely want labor. It wanted a dependable labor force shaped to fit the rhythm of the line. That is why the Sociological department is not a side note. It is central to the Ford system. The same company that learned how to move a chassis from station to station also learned how to attach wages to standards of life. The same drive for efficiency that reduced assembly time also expanded the reach of supervision. The same factory that helped make the Model T more affordable also helped define a new relationship between employer and employee. This is the deeper meaning of welfare at Highland Park. It was not separate from discipline. It was one of discipline's forms. The Ford system promised abundance, more cars, lower prices, higher wages, shorter hours. But it also asked who would set the terms of modern work. Would the worker's relationship to the company end with the shift? Or would the company claim a right to examine the life that made the shift possible? At Highland Park, Ford's answer was clear enough. The factory gate was not the boundary of management. It was only one boundary among many. The line had organized motion inside the plant. The wage and the sociological department extended that organization outward into the habits and homes of the people who made the line run. This is why Fordism would become more than a way to build cars. It would become a social model, admired for its productivity and criticized for its control. Highland Park's legacy would not rest only on chains, conveyors, interchangeable parts, or the Model T. It would rest on the full bargain Ford helped make visible: faster production, cheaper goods, higher wages, narrower jobs, and a managerial reach that followed workers beyond the place where the machines stopped. By the time the line at Highland Park reached beyond the factory gate, the story was no longer only about a car plant in Michigan. It had become a way of thinking about production, wages, discipline, and modern life. The moving assembly line did not simply change the path of a Model T chassis through Building H. It changed the assumptions around work itself: how fast a task should be done, how narrowly it could be divided, how closely it could be timed, and how much of a worker's life a company might try to organize in return for steady pay. That larger pattern is what later came to be called Fordism. Britannica frames Fordism as the mass production of standardized goods on a moving assembly line using dedicated machinery and semi-skilled labor. It is a concise definition, but inside it is almost the entire Highland Park story. Standardized goods meant the Model T could be built again and again with parts that fit a common design. Dedicated machinery meant tools and factory arrangements were increasingly shaped around specific, repeated operations. Semi-skilled labor meant the work could be broken down into narrow tasks that did not require one worker to master the whole automobile. And the moving assembly line meant the product itself carried the rhythm of the factory forward. At Highland Park, these elements were not abstract ideas. They were physical arrangements. A frame began its journey. Axles were added. Gas tanks, engines, dashboards, wheels, radiators, and bodies followed in sequence. In 1914, wheels and radiators could be conveyed to a platform and slid down ramps, incident degree flip. By early 1914, a chain-driven chassis line was in operation. By mid-1914, 3 parallel chassis lines were running. The result was not just a higher number of cars. It was a new relationship between movement and labor. The old station method had gathered work around a place. The Ford system gathered workers around a moving object. That difference sounds simple, but it remade the factory. The worker no longer controlled the pace in the same way. The line carried the work forward. The task became smaller, more repeatable, and more measurable. Management could count, compare, adjust, and accelerate. Productivity became visible in motion. That is why Highland Park cast such a long shadow. It helped establish the factory as a timed system, not merely a large building full of machines. Albert Kahn's glass-filled plant, the Crystal Palace, had given Ford Motor Company space, light, and organization for high-volume production. But the deeper legacy was not architectural beauty. It was coordination. The Highland Park Plant fused architecture, material flow, subdivided labor, specialized machinery, wage policy, and supervision into a single industrial model. Still, if Fordism bears Ford's name, the history requires care. Henry Ford was central to the mass-produced automobile, but he was not alone. Britannica cautions against treating him as the only figure in this transformation. Ransom E. Olds had earlier pursued a mass market with the curved dash Oldsmobile in 1901. Other industries and manufacturers had worked with ideas of standardization, flow, and divided labor. Ford's achievement was not that he invented every part of mass production from nothing. It was that, at Highland Park, he and the company integrated these parts at a scale and with a force that became a model for others. That distinction matters because it keeps the story human and historical. The moving assembly line was not a bolt from the sky. It developed through experiments, pressures, failures, and adjustments. The first crude Ford moving assembly line at Highland Park was not a full automobile line. It was the April 1913 Magneto line, where workers placed V-shaped magnets on Model T flywheels and pushed the workpiece along to the next worker. From there, the system expanded. In a 1913 assembly scene, workers still pushed or pulled vehicles between stations while a chain hoist lowered engines onto chassis. The famous line arrived through practice. It became powerful because it was refined.
And once refined,
It changed the social meaning of the Model T. The car itself was never only a machine.
it became evidence of what the factory could do.
Ford produced more than 15 million Model Ts during the model's production run from 1908 to 1927.
The price fell dramatically over its lifetime,
From $850 at introduction to about $260 by the mid-1920s.
Those falling prices were not a side note. They showed how production engineering could reach outward into everyday life.
The factory's discipline helped turn the automobile from a luxury item into a mass consumer good for many American households. But the same process that made the car more affordable also made the job more repetitive. That contradiction is at the center of the Highland Park legacy.
The line made goods faster and cheaper.
It also narrowed work. It reduced the range of motion, judgment, and control many workers had over the day. The same system that raised output helped produce the worker turnover that alarmed Ford at the end of 1913. The same company that announced the $5 day on January 5, 1914, also tied that promise to conditions monitored through the Sociological department. Higher wages, shorter hours, and managerial oversight grew together. So Fordism was never just a technical system. It was a bargain, and not everyone experienced that bargain in the same way. For customers, it could mean access, a cheaper car, mobility, and participation in a new consumer world. For workers, it could mean higher pay and an 8-hour day, but also monotony, pace, and scrutiny. For managers, it offered a vision of control. If every motion could be simplified, timed, and coordinated, then production could be made predictable. Highland Park became the place where that vision took form. Its later historical recognition reflects that importance. The Highland Park Ford plant was listed on the National Register of Historic Places in 1973. In 1978, it became a National Historic Landmark. Those designations placed the factory within the official memory of the United States, not simply as an old industrial site, but as a place where a major transformation in work and production had been concentrated. By then, the world had long since absorbed the meaning of the moving line. The phrase assembly line had moved beyond automobile plants. It became a way to describe efficiency, repetition, standardization, and sometimes dehumanization. To call something assembly line work was to suggest that it had been broken into parts and paced by a system larger than the person doing it. That language is part of Highland Park's shadow, too. The plant helped give modern society a new vocabulary for productivity and its costs. The rivalry in this story was never only between Ford and other automakers. It was also between ways of organizing life. One model prized craft, broader skill, and worker control over the pace of labor. Another model prized flow, speed, uniformity, and managerial coordination. Highland Park did not erase the older world all at once, but it demonstrated how powerful the new one could be. That is why the factory before the myth matters. If the story is told as the tale of one inventor and one sudden breakthrough, the deeper lesson disappears. Highland Park was not a single machine that changed work forever. It was a system that made the machine, the building, the worker, the wage, and the product depend on one another. It joined the moving line to the mass market. It joined efficiency to repetition. It joined higher pay to closer supervision. The Model T rolled out as a car. Fordism remained as a pattern. And in that pattern, the promise and the warning were always side by side. Faster goods, cheaper cars, narrower jobs, higher wages, deeper managerial reach. Highland Park made those forces visible in one place, under glass roofs and along moving lines, in the city of Highland Park, Michigan, just outside Detroit. Its legacy is not that it solved the problem of work. It is that it defined one of the modern world's most influential answers to it.